Okay, so we're going to follow this single, tiny speck of dust on a pretty epic journey. I mean, this trip starts way out at the edge of space, it hurtles through our atmosphere, and it ends up right here, on the stage of a powerful microscope. And look, this isn't just any old dust. You got to think of it as a 4.5 billion-year-old time capsule, a totally pristine messenger from the very birth of our solar system.
So that brings up a really central question, doesn't it? When a piece of the cosmos literally falls into your hands, how in the world do you handle it? Where do you even begin?
And, well, the answer kind of sets the stage for this whole thing. When your cosmic visitor is smaller than the width of a human hair, every single move you make has to be just unbelievably precise. Because one wrong touch, one little stray particle of earthly dust, and all those ancient secrets locked inside could be lost forever.
All right, so our story kicks off miles and miles above the Earth's surface, up in the thin, frigid air of the stratosphere. The very first mission, you have to go fishing for something you can't even see.
The ingenuity here is just incredible. So scientists use these high-altitude planes, like the famous U-2, to basically stick these collectors out into the wind. And these collectors are pretty much just flags coated in sticky stuff. That stickiness comes from silicone oil, which is perfect because it doesn't freeze up there in the crazy cold of the stratosphere. So as this interplanetary dust drifts down, bam, it gets caught. Then, before the plane even thinks about landing, the flag is pulled back into this sterile container they call a coffin to keep this precious cargo safe from all of our dust down here. So once it's back on the ground, the particle's biggest enemy is, well, everything. Every surface, every person, even the air itself. And that's why it's immediately taken to a kind of fortress, an ultra-clean sanctuary where the war on contamination is fought 24/7. And this right here, this is the heart of that fortress. It's an actual hand-drawn blueprint from the scientists themselves. And it shows you this isn't just some clean room, it's a meticulously planned environment. It has controlled zones, specific airflows, all of it designed for one single purpose, to protect the sample from us. And inside, you better believe the rules are strict. I mean, really strict. Every single surface is categorized. So Category 1 surfaces, that's the holy grail, only for perfectly clean equipment. Category 2 is for your general work with clean gloves. And Category 3, yeah, you don't want to touch that. Touch that and your gloves are instantly considered contaminated. It's this constant high-stakes game of awareness. You know, this whole process, this discipline, it starts before you even set foot in the room. Just getting in is a whole ritual. You put on shoe covers, then you step on a special tacky mat to pull off any little particles. Inside, absolutely everything is handled with gloves. And if you're getting anywhere near an open sample, you're in a full-on bodysuit. It's like you're preparing for surgery on a cosmic scale. Get this, even the air is a tool in here. The room is constantly being bathed in this downward flow of hyperfiltered air. It's called laminar flow, and it's designed to push any stray particles down and away from all the work surfaces. Scientists even have to be careful about where they stand, so they don't accidentally block the flow and create a little vortex of contamination. Okay, so now we're inside the fortress, all suited up, and this is where the real challenge begins. It's like a microscopic obstacle course to find and free just one single target particle from that sticky silicone oil it was caught in. So that first move, it's just unbelievably delicate. A researcher is looking through a microscope, using these joystick-like controls, it's called a micromanipulator, to guide a glass needle with a tip that's only 5 microns wide. They hunt for a promising-looking particle, carefully pluck it out of the oil, and then transfer it inside a tiny drop of that oil onto a special filter. And here's the crazy part, the irony of it all. That silicone oil was the hero of the story, right? It's the whole reason we could catch the particle. But now it's the villain. To actually analyze the particle itself, every single last molecule of that oil has got to go. So how do you solve that? Well, you don't just buy something off the shelf. Nope, you build it. This diagram shows the actual setup they designed. It's a custom-built washing machine for a single speck of dust, complete with a pipette, a filter, and a hookup for a vacuum pump. So here's how this little micro shower actually works. The particle sitting on its filter is placed in the chamber. Then it gets washed over and over again with a solvent called hexanes.
A vacuum pump gently pulls the solvent through the filter, making sure there's this nice, uniform flow that carries all the oil away but leaves that precious particle perfectly in place.
All right, so after its bath, what happens next really depends on what you're trying to find out. If you're using a scanning electron microscope, or SEM, which basically looks at the particle's surface in 3D, it can often just stay put. But for the much more powerful transmission electron microscope, or TEM, which lets you see through the particle to its internal structure, well, it's got to be moved one last time.
This final stage, man, it's like a microscopic treasure hunt. It is the ultimate test of a steady hand. To get it ready for the TEM, the particle has to complete one last, incredibly precise journey to its final home.
The level of detail here it's just mind-boggling. Seriously, the particle gets picked up again and placed on a super thin carbon film. A tiny little copper grid is placed over it. Then this whole thing is floated on deionized water to separate the film, which is then scooped up with a loop and placed on a pedestal to dry. The final result? A single particle, perfectly positioned, finally ready for the TEM.
So let's just take a step back and recap this wild ride, right? It was captured way up high in the stratosphere, plucked from oil in a fortress-like clean room, washed with custom-built machinery, and finally mounted on a microscopic pedestal. That is a truly immense amount of effort for one tiny, tiny traveler.
And just to really put this all into perspective for you, that needle tip they're using is 5 micrometers wide. To give you some context, a single human red blood cell is about 7 micrometers across. They are performing surgery with a tool that is smaller than one of your own blood cells.
And that really brings us to the final question. All of this, the high-altitude planes, the clean room fortress, the microscopic obstacle course, it all leads right here. What secrets could possibly be locked inside that tiny speck of dust? Secrets about the very birth of our solar system that would make all of this incredible effort worthwhile.